That's a very easy.
Okay, 5-3 graphing radical functions. We are only going to do what kind of radicals? Square roots. We are not doing cube roots. We are only doing square roots. Now, I made a promise to you at the beginning of the year that any equation that I gave you, I would tell you an H and a K, right? And the H would always do what to the graph? Move it left or right. And the K would always move it up or down. And A would always make it wider or narrower, right? Yes. And the negative in front of A would reflect it over the x-axis, right?
Yes.
And the negative in the function would be the y-axis. I promised you that, no matter what I taught you, right? And
Well, now you're changing it.
It held true for parabolas, right? And then we did absolute values. We did our rationals. I even showed you how to use that in the rational, but then we had an easier way after that, didn't we?
Linear.
In linear. I showed you in linear. So now I'm going to show you in radicals. And I promise you guys it's going to do the same thing. I'm never going to take that away from you. So in pre-calc next year, every time we do any of them, okay? When we do sine and cosine and tangent functions, they're still going to have an H and a K, and guess what they're still going to do? Left and right and up and down. So anything I ever teach you, I promise you that. Now, after you leave this building, I don't know if a teacher will make that promise to you, but I promise you that I will always teach it to you that way, because that is the easiest way to sketch these things. So our learning goal is to graph radical functions and specifically square roots. Okay, when I put this grid up here, I don't want to sketch, do I? I want us to find points and do exactly. I'm not giving you graph paper. So we're going to get to the point where we just sketch it. Remember we talked about before, left, right, where the vertex went, correct? And we did domain, and then we did wider, narrower, and then we made a sketch. That's what we're looking for, but we got to get to that point first, okay? So this is our parent function, y equals the square root of x. We know that the square of x is the inverse of x squared. We already know that, correct? And what does x squared look like? Everyone in the air draw me an x squared. Okay, what shape is this? Parabola. Okay, and we know it's an inverse, so a parabola will look like this. How about I draw it, not erase it? A parabola looks like that, correct?
Yes.
And the inverse went like this, but is that an inverse function if it goes like that?
No.
No. So we had to take away half of it, didn't we? We took out this, and we took away the bottom half. So we know when we take the square root, it's really plus or minus, correct? But if I do the plus and minus, I don't get a function, do I? So when I'm trying to get a function, I'm only going to do the plus. So we're going to make a table, just like any other function, no matter what it is I give you. If you didn't have a clue how to graph it, could you throw numbers into it? Yes.
Yeah.
We know it's going to be kind of curvy looking, don't we?
Yeah.
And to me, it kind of resembles a square root function, a square root symbol, if you think about it. So what are some numbers you want to throw in there? Now, we're going to take the square root. How about we start at where?
2.
0.
Okay, that means that's logical to start at 0, right?
Yeah.
What about anything negative? First of all, you don't have anything negative here, but why?
Because you can take square root of negative number.
You can't take the even root specifically of any negative number, can I?
No.
It's imaginary. So it's over here somewhere, but it's imaginary. So we're going to start at 0 because I can take the square root of 0 and get what? 0. Okay. I want nice numbers. I can pick anything I want.
149.
I have a 1 first. Why was 1?
Square root of 1 is 1.
1. And then Evan, I'll take your 4. And then 9. And then 16.
Yeah,
Okay.
121.
So we can keep going, right? But my graph only goes to 10, so can't even do the 16, can I?
No.
Okay, so square root of 1 is
1,
then.
2, 3, 4.
Okay, so I'm going to graph it. So 0, 0, 1, 1,
4,
4, 2,
1.
and then 9, 3.
Yeah.
Okay, and it's going to do what?
Look like that.
Look like that. And it doesn't go down. Mine tend to go down. It shouldn't go down. What's it going to continue to do?
Go up.
It's going to continue to go up, isn't it? Okay. So what is the domain of this?
What were we looking for?
No. You just told me you couldn't take a square root of a what?
0. A negative number.
A negative number. I can't take a square root of a negative number, can I?
No.
And look at the picture. What's the domain?
X has to be greater than 0.
X has to be greater than equal to 0, right? So x such that x is greater than equal to 0. Here we go. Range. Range is also 0, isn't it?
Yes.
So when I start moving this graph around, is that going to affect my range and my domain? Yeah. Okay. Where is my vertex on this graph?
0,
0, 0. That's that anchor point that we are going to move with my h and my k, isn't it? Oh, increasing or decreasing? Increasing. How can I make it decreasing?
Negative flip then.
A negative in front of it. Yes, that would reflect it, Evan. But I'm sure that was Ethan that said negative, didn't he? Okay. So, but you said flip it. Okay, so I use the word reflected for big kids. Okay, so a negative in front of a negative in front of that square root would reflect it over the x-axis, wouldn't it? How would I reflect it over the y-axis? Where would I put that negative? In the function, right? In front of that x. Okay, so all that stuff still happens. You guys have learned something this year. Look at you. Okay.
How to color shamrocks effectively?
Yeah.
Efficiently?
No, some of us still haven't learned that. Yes.
How is everything 0 like I didn't hear you.
Okay. So what are you wanting?
Like how is the domain range?
Okay, so I can't put a negative. I cannot take the even root of a negative number. Correct. So 0 is the first non-negative number I can take a square root of. So that's why my domain is greater than equal to 0. Okay? Now my range is what's coming out of it. And so if I'm always going to put a positive number in, I'm always going to get out a what? Positive number. So our vertex, our anchor point that we're going to move around with our h and our k is at 0, 0. So as we move that around, like if I moved my 0, 0 went to -4, -6. How would that change my domain and range? My domain would now be bigger than -4, right? And then my range would be bigger than -6. So that 0, 0 is going to affect that domain and range. We're clear now?
Yeah.
Okay, thank you for asking the question. Okay, so what's going to happen here?
Well, you're gonna take everything times 3.
I'm going to take everything times 3, right? Before I do what? Before I take the square root. So is that going to change the kind of numbers I put in here?
Yeah.
Yeah, definitely. Okay, so, and I have a graph there again, so that means I got to find points, right? Can I still put 0 in?
Yes.
Yeah? Okay, so 0, and 3 times 0 is 0, the square root of 0 is 0. Okay, so we're still good there. What about 1?
No.
Yeah, square root of 3.
I could do it, right? But can I graph the square root of 3
No.
effectively?
Not very.
I know it's like 1.6, right? How did I get 1.6?
Because between 1 and 2.
Square root of 4 is 2, right? And the square root of 1 is 1, so it's probably going to be closer to 2 than 1. Okay, so I think it's like 1.6, I don't know. It's bigger than 1.5, I know that. Okay, so 1 is not going to be affected for me.
What about
3,
3,
12.
3, 12.
3 would be good. I need something between 0 and 3.
That's gonna be
Because
12.
12 will work, but do I have 12 on my picture? No.
2.
2?
You said 0 and 3, and 1 won't work, so 2.
There's other numbers in there. What number could I multiply by 3 and get 1?
3 will.
Because you want 1.
Third.
3 will work.
A
3
third.
will work. We will do 3.
Oh, I thought we were like moving on.
I want I want a number between 0 and 3.
A
Third.
A third. Why a third?
Because you
then
get
you'll
1.
get 1.
You get the square root of 1.
I'll get a third of 3 is 1, and the square root of 1 is 1.
1.
Okay? Now we can do 3 now, if you would like.
Yes,
Okay, so 3 times 3 is 9. Square root of 9 is
3.
3. Okay? Give me another number.
5 and a third.
Well, 5 and a third would work, but you'd end up with a square root of 5. What about 4/3? Why'd I pick 4/3? So 4/3 times 3 would just be 4, and is 4 a perfect square? Yeah, but 4/3 should be where? Should be like right here, shouldn't it? So 4/3 would be what? 2? So we got 4, right? And then we got 9 with the 3. What's the next perfect square? We got 1, right? We got 0. This was 0. This ended up to be 1. This ended up to be 4. This ended up to be 9. What's the next one?
9/3.
Well, 16.
16/3, right?
No.
Perfect
Yeah.
squares? Perfect squares. 1, 4, 9. What's next? 16. So 16/3. So it'd be 4. Because we have to, the 3's reduced, right? Okay, so what would the next one be?
25/3.
25/3.
Damn, smart.
And what would 25/3 be?
5.
5. Okay, do you see how my problem dictated what I wanted to throw in there?
Yes.
Yes. I can throw anything I want in there, but do I want to try to graph the square root of 3?
No.
No, I can figure out a third, can't you? I mean, we can kind of judge a third. I definitely don't want to do the square root of 3 if I don't have to. So do you think we have enough points that work?
Yeah.
Okay, so 0, 0.
1.
1/3, 1. Close enough to a third?
Yeah.
Okay, and then 4/3, well 4/3 is 1 and a third, correct?
Yeah.
So 1 and a third, so that was what, 2? And then 3 was 3. And 16/3 is 5 and a third,
Yeah.
Yeah, it is.
Probably.
and that was 4. And then 25/3 is what, 8 and a third? Is that computer in your way? So then 8 and a third is 5. So what did that 3 do to it?
Made it wider.
It made it wider. And when we say wider, it's kind of a rough interpretation of wider because it's wider based on the x-axis. Everyone get that? When we say
Yeah.
wider, it means further away from the axis. Narrower would be what?
Closer.
The book, if you ever got a hold of an answer key, would say it has a vertical stretch or compression. It's wider or it is narrower. Why would I use something that would confuse me? Okay? Because I can compress things either horizontally or vertically, correct? Like, I can describe that in either way. So to me, it doesn't make sense to do that. So, that 3 inside made it wider. What would happen if I put the 3 outside?
No.
It would still make it what? Wouldn't it still make it wider?
Yeah.
Because we had 1, and then what did we do? 4, right? 4, and then 9, and then 16. Oh, 0. Okay, so if we did that, we originally had, when it was just x squared, yes? Or square root of x. We had 0, 1, 2, 3, 4. But what would I have to do with every one of these? Multiply times what? So it would be 3, 6, 9, 12. So is that going to make it wider also?
Yeah.
How would I make it narrower?
You
Put it
take
on
it away
the
the
others.
3.
Wouldn't that make it narrower?
Yeah.
Because that would divide everything by what?
3.
3 when you were done. So remember that A, if it was greater than 1, it's wider. If it's less than 1, it's
Narrower.
narrower. Great. That's opposite. Said that wrong. In a parabola, when it was greater than 1, it was narrower. Yes. Because it increased quicker.
Oh, yeah.
Yes. But when it was less than 1, it was wider because it increased slower. Why does it do it opposite here?
Because it wants to be different. It wants to show.
What's the relationship between x squared and the square root of x?
A 3.
They're inverses, yes?
Yes.
Yeah.
So inverses interchange what two things?
The X and Y.
The X and the Y. So wouldn't it make sense that the effect was opposite also?
Yeah.
Yes? Okay. So, what happened here?
Square root of x half.
Oh, wait, did the domain or range change?
No.
No, still 0 and 0, right?
Yeah.
Why?
Because
Because the vertex on the road.
The vertex didn't move, did it?
You have something on it.
And did the increasing decreasing change?
No.
No, because I didn't throw a negative out in front of it, did it?
No.
Okay, what's going to change here?
the Y.
The vertex.
The vertex is changing here, isn't it?
Time.
Now we can do the math, but should we know what happens to this?
Yeah.
What happens to it?
It moves
Five
to
which
the
way?
Right.
5 to the right, doesn't it? Everything to the right went 5. How did you know that?
Because H.
Because it's an H, because it's in the function, and Mrs. Mick promised me that that would always do the same thing, right?
I don't remember you saying that. I distinctly
So-
remember saying those exact words.
We had 0, 1, 2, 3 before, yes?
Yes.
What is going to happen to every single one of those things
Gonna
now?
shift 5
It's
to
going
the right.
every single one is going to go 5 to the right, isn't it?
Mm-hmm.
So 0, 0 is now going to come to what?
0,
5 0.
5, 0. And 1, 1 is now going to come to
1
6, 1.
6, 1. You're adding it to the wrong one.
Yeah.
Okay?
It's gonna
And
be
this 4, 2 is going to go to
9,
9, 2. Now, do I have room to do any more?
2.
No. But it's still going to have the same shape, isn't it?
Yes.
Is the width going to change at all? No. Is the domain going to change?
Yes.
Everything went where?
To the right.
Right 5. So it was greater than equal to 0. Now it is greater than equal to what? 5. Oops, I did that wrong. Anybody still doing interval notation for this?
No,
Has everybody graduated to interval? I mean,
I
Seth?
forgot interval is
you forgot. What is interval notation of this? Anybody?
0,
0.
5, 0.
5 bracket. Why is it a bracket?
Oh,
Because it cannot equal. It's a solid.
because it can equal.
It can equal. And where's it stop?
Infinity.
0.
Where are you getting 0?
Sideways 0 with another 0 attached to
Where are
it.
you getting 0? It goes there, right? And why is that a parenthesis?
Because it can't touch
It
infinity.
can't ever get to infinity. Yes, ma'am.
I don't know why, but I guess I've forgotten how to graph because you're okay. So I don't know. It goes X, Y.
Yes. So this was originally 0, 0 for the vertex, yes?
Yeah.
And now
it's
the
0,
vertex,
5.
we've added 5 to
5,
the
0.
x's, so it's gone to 5, 0. So every x gets 5 added onto it. Did that clear that up?
Yeah.
Okay.
Does the range stay the same?
Oh, why would the range stay the same?
Because that's the X's and the X's are the same.
No, x's aren't,
Or the
great,
Y's.
the y's,
That's what I
thank you.
meant.
I knew what you meant. The y, it didn't go up or down, did it?
No.
So the y is gonna be, so this change right here, is that gonna be my key really to my range and domain?
Yes.
Yes, but you gotta be careful because what if I reflect that over the x-axis?
But it's bad news.
So this, if I put what if I put a negative right here? What would it change with my picture?
Be on the other side of the X.
It would be like this, right? So would it change my domain?
No.
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 Would it change my range?
Yes.
It wouldn't be greater than 0, it would be
less than 0.
less than 0.
Or equal.
So we gotta be, sometimes it's easier to do our range after we graph it, isn't it?
Yeah.
So,
So if it's under the x-axis, it's less than.
yes, because it's decreasing. Anytime it's decreasing, it's gonna be a less than. Okay, so we've already talked about it, but this is exactly what I promised it would be. that seems a little small, but a radical function is A, and A changes my width, yes? And they say stretch and compression, but wider or narrower. If there was a minus out in front of this A, it would do what? What's the minus in front of the A?
It would reflect.
Over the X,
Yeah,
right?
axis.
Okay, what's that H do?
Moves it left or right.
Left or right? And the K?
Up or
It
down.
Up or
determines
down?
a vertical
I'm
translation.
gonna tell you that my K's usually on these end up in the front. Why do you think they end up in the front?
Because that's how you go like for when you solve
Cause it's easier.
Well, for my brain, I definitely close my radicals. Definitely, okay? But if I would put this K up here, I'd have like K plus or minus A, the square root or the nth root of X minus H. Would I know definitely that that's a K now and not like a bad written radical sign? I've already helped 2 different people, and one of them, the radical sign went across everything. So they had their K in the radical. Is that gonna work out for you? No. And then another one that just put it over the X and stopped. Is that gonna work out for you? No. You gotta make it look like what it is. Okay, but does it change anything if I put that K in the front? No. Doesn't make any difference. Okay, so now look what disappeared. What disappeared? My graph. So am I looking for an exact graph anymore?
Yes.
Nope, I just want a nice sketch.
Sketcheroo.
Okay. Do I need to know the vertex though?
Yes.
Yes. Do I need to know whether it's wider or narrower?
Yes.
Do I need to know whether it's reflected? Yes. And then domain and range?
Yes.
Yes. So I need to know those things, but the picture's just for me to have an idea, right?
Yes.
So graphing isn't really always about the picture, it's just knowing what's happening. Okay? So I'm gonna go across. Is it reflected?
No.
No.
So 2 is positive. Is it reflected?
No.
No. So if you want to say no reflect, that's fine. Or do you have to do anything with it?
No.
No. Okay. What's the 2 tell me?
It is wider.
It's wider. And wider than what?
Wider than the parent.
Than the parent function, the original, right? And when we talk wider, it's just from that axis of the curve, right? It's just further away from the axis of the curve. Okay, and so 0, 0. What is 0, 0? The vertex. It was of the parent function, yes. It was 0, 0. Now where is it at?
Negative 3, 5.
Negative 3, 5. Now, does everybody, or would everybody told me that it was a negative 3, 5?
Probably not.
Why is it a negative 3, Garrett?
I said so.
Cause you had,
What's the formula? Minus, correct?
yeah,
And what do I have here? Plus, and 2 negatives make a...
Wait, 2 negatives.
when you multiply, when you add them, they make a negative. 2 negatives multiply to a positive, correct?
Yes.
Okay, so remember that H is always the opposite, isn't it?
Yes.
Okay? Everyone else would just only 5, right? We got 5?
Yep.
Don't forget that negative. We're gonna do domain and range. Would we like to make an educated guess right now? Or,
Yes.
yes?
Yeah.
And I'm gonna tell you, you're probably gonna be right.
Oh my god.
It's gonna be
Ouch.
Literally my soul is in my body.
Same.
Not the way that
scared me so bad.
Very loud.
What would you do if I had a heart attack? Okay.
Stop the recording.
Sue her.
Thank you. Thank you. Actually, you should leave it, then I would have record of what happened.
I would rejoice if you had.
No, that's the
Okay, so when it's no reflection, is it still gonna be that greater than 2 equal? The only time it's really gonna throw you off is when it's a reflection. If the Y reflection or an X reflection. And I don't think there were any Y reflections, I could be wrong. Okay, so domain, X such that X is gonna be what?
Greater
Greater
than
than
5.
negative 3.
How about the X
Negative
value?
3 equals.
That comes from the X of the vertex, correct?
Yeah, I have it
Or the H specifically. Okay, Y such that Y is greater than or equal to 5. So we need a graphic, correct? suppose.
No, I don't
So
suppose.
1, 2, 3, yes. 1, 2, 3, 4, 5. So my vertex goes 3 and 5. Now, sometimes we know that this is going to go this way, yes? We know it's going to go like this. But sometimes it's nice to know the y-intercept, isn't it?
Yeah.
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 So what is the x value at a y-intercept? What's the x? 0. So I can find it by plugging a 0 in for the x, right? So let's see if we can figure that out. So we have the y-intercept, because we've done this before, right? So I would have y equals 2 the square root of 3 plus 5. Okay, we can't take the square root of 3, can we?
Not
No.
very efficient.
Okay, so if we say the square root of 3 is like 1.6, I'm sure it's not, but okay, if it's 1.6, 1.6 times 2 is 32, right? So 3.2?
Yeah.
1.6 times 2.
Yes.
Okay, is 3.2. Plus 5 would be
8.2.
8.2. So as long as this is 8, we're good, correct? You get what I'm getting at? As long as it hits above 8, we're good. Now, I'm not saying you have to do the y-intercept, but would it be a bad thing to do to remember how to do it? No. And sometimes it might work, right? Sometimes you might get like the square root of 4 and then be 2. If we got the square root of 4, it'd be 2 times 2, which would be 4,
Four.
plus 9, plus 5 would be 9. And we know that is 9. We just don't know it, do we? Okay, so did we approach this the same way we did parabolas and absolute
Yes.
values? Yes, that's what I expect you to do. I don't expect you to reinvent the wheel. Do exactly what you've done before. You know how to do this stuff, continue to do it. The shape is the only thing different. Doesn't it kind of look like a square root? A bad written square root, but
Looks more like a parabola.
See?
That'd be a horrible, that,
that'd be a
It's
half
looking
of a
like you
parabola.
said.
Yeah,
It's
not a
parabola.
parabola. It still looks like a parabola.
Okay, so what's gonna happen here? Is it reflected? Oh, let me let you write it down, sorry. G of x equals 1/2 the square root of x minus 1 minus 3. Remember, end in that square root will save your life. I just can't put it in the computer. I wish I could make the computer end it.
So there is no reflection.
Okay, no reflection? Why?
Because it's not negative.
What's not
The
negative? The A? No. Okay, so no reflection there.
Narrow.
It is gonna be narrower.
Narrower, because the 1/2, right? But if it was a parabola, it'd be wider with the 1/2, wouldn't it? Because it would squish it out. Okay,
It is down 3.
okay, so 0, 0. Why do we always talk about 0, 0?
Because that's the parent.
That's the parent
That's
function,
not the
right?
parent.
Okay, so 0, 0 goes to
One minus
negative 3.
one.
Negative
1, negative 3.
Domain
Domain,
would be x such that x is
Is-
greater than or equal to 1.
okay, that's gonna be the same, it's just gonna have that movement, because there's no reflection, right? If we had a reflection, would it change one of those? Yes. If it reflected over the x, it changed the range. If it reflected over the y, it would change the domain. Okay, range. Assuming you've already written it. Such
Y
that,
is greater than
Negative.
-3.
Okay.
oh. Remember your arrows on your positives, right? Okay, how do we wrap this then? How do we start? What do we do first?
You set
Draw the
your
graph.
point.
You just draw the graph?
No, you find where.
You have to find my vertex, right? So 1, -3. And this is such science, right?
What?
And remember, this is my new, like, axis right there, right?
Yes.
So we said narrower, so it has to be kind of closer, doesn't it? And
Up one over two.
no, we're just doing a sketch. Now, the other one we did the x-axis, correct? Yes?
Yeah.
What is this one eventually going to hit?
The y-axis.
I mean, we did the x-axis, the y before, we're eventually gonna hit the,
X-axis, so
so how do you find an x?
you
What's that?
zero for y equal to 0.
So y equal to 0. So that'd be 0 equals 1/2 the square root of x minus 1 minus 3.
Add 3 to both
So
sides.
add 3 and multiply by 2.
Yeah.
So that's 6 equals the square root of x minus 1.
Square both sides.
Square both sides. So 36 equals x minus 1.
So x equals 37.
So x equals 37. So my x-intercept is 37, 0. I'm obviously not going to go out to 37, 0, correct?
Yes, we are.
But did I just review some skills that I've been doing, and it's always good for me to do? And if it was like 3, I could put it through there and have a pretty good graph, couldn't I?
Yeah.
Without having to put a whole table worth of stuff and plot points.
Is that a 6 or a 0?
It was a 3, then we turned it into a 6 because we multiplied it by 2.
No, that looks-
Hey, but the reason why I'm throwing stuff in like this is, did we do the same thing when we did rational functions to find an x and a y-intercept? It doesn't change what function I'm putting in front of you. Do you find the x-intercept the same way every single time?
Here's that way.
And the y-intercept every single time? It's the algebra to undo it that changes.
That's the numbers that change.
Okay, so now this one says, how can I rewrite the following radical functions to identify its transformation from the parent function? Those look horrible. Not horrible, but we can rewrite them and help ourselves out a little bit.
No.
Not one
When-
you can.
This is 9 times x, correct?
Yes.
So it's really the square root of 9 times the square root of x, yes?
So
So what's the square root of 9?
3.
3. Square root of x. So do we need to list everything again, guys? Do you want to list everything?
No.
Are we good?
We're good.
Okay. Vertex is 0, 0, 0. It hasn't moved left or right, has it? Has it?
No.
Nope. So is the domain going to change?
No.
Nope. Is the range going to change?
No.
Nope. The only thing that is going to change here is what?
Like the
3.
What's the 3 do?
Y's.
A.
Yep. What's it do?
Makes it
Wider.
wider.
It makes it wider. So it makes it wider. So I can sketch this, correct?
Yes.
And make it wider. So the only thing it affected, on these guys, just tell me what it affects. If it doesn't affect anything else, you don't need to write it. Got it? Now the other one, we don't get so lucky.
No.
No. Okay, well, like this, we made it was multiplication, right? This is not multiplication. Can I make it to multiplication of two things? I've got 4x plus 16.
I mean, you can square both of them.
You can, because it'd have to be x.
Just the 4x plus 16. Can I make that into a multiplication problem? 4 and 16. Do they both have 4 in common?
Yes.
So can I factor it?
Yeah.
So I have 4 times x plus 4, correct?
Yeah.
Plus 7. Well, this is the square root of 4 times the square root of x plus 4. So what's the square root of 4?
2.
2. So I could rewrite this as 2 square root of x plus 4, couldn't I? Now, is that something we've been dealing with and easier to deal with?
Yes.
Yes.
It makes it wider.
Okay, so now what's going to happen is it's going to make wider,
And the vertex is gonna zoom
and 0, 0 is going to go to
-4, 7.
negative 4, 7, and the domain is going to go to
X such that x is greater than or equal to -4.
and the range is going to change to
Y such that y is greater than or equal to 7.
So, when you came in today and I told you we're going to have to do this, you were going to think, this is impossible. Is this impossible? No. A little bit? No.
To the head. graph time.
Nope, we're not gonna grab it.
No.
I don't have room. But could I?
Yes.
So I do, I guess we can.
She's gonna graph it.
Well, he said to graph it.
It's
1,
actually-
2, 3, 4, right?
He also
1, 2,
doesn't
3,
know how to
4,
code.
5, 6, 7. And so 4, 7. And it's gonna do what?
Wider.
Oh, it's wider. And it's wider, and sometimes putting this imaginary new axis helps you get it wider or narrower also. Let's do some more. Now, last hour they decided that they were going to factor out 3.5. Well, 3.5 goes into 7, yes?
Yeah.
Well, when I was doing my notes, I didn't. I made 3.5 into a fraction, and I factored out everything that would, like, I just factored out a bunch of stuff. Because I don't want the 7 in front of the x. Do you want the 7 in front of the x?
No.
Okay, so what do you want to do? It doesn't really matter. We know how to deal with it, and we can deal with the 7 in front of the x. You know that 3.5 times 2 is 7. I hope everyone in here does. So you want to make it a fraction, would be 35 over 10, right? So it'd be 7 over 2. So do you want to make it 7 halves, or do you want to make it 3.5? 3.5? Okay. Chickens. My way gives you 1 as a coefficient for x. Ethan, wake up. Okay, so if I'm going to factor out 3.5, what do you have left?
2x.
2x
1.
minus 1 minus 10. Okay, so this would be the square root of 3.5, yes?
Yes.
So the square root of 3.5. And then the square root of 2x minus 1 minus 10. So this right there, that's a number, yes?
Yes.
Yes? And this, we know this, we were judging the square root of 3 was like 1.6. Well, so the square root of 3.5 is still bigger than 1, yes?
Yes.
So what's it gonna do to the graph? Wider. Okay, it's wider.
It's gonna be.
And then, you need to be careful though, on this, and we've had this happen before. If there is a coefficient on x, do you have to find that movement differently?
Yeah.
You have to set your radicand equal to what? 0. So I have 2x minus 1 equals 0. So add 1 and divide by 2. So 1/2 negative 10. The way I would have done it, you would have just been left with 1/2. And you wouldn't have to do that. Just
That
saying.
wasn't very hard.
Okay, but you have to remember to do it, don't you?
Yeah.
Because you can't just say it's 1, can you? Why couldn't I say it's just 1?
Because you're wrong.
Yes, that would be wrong. What made it that way?
Because you have to take everything into 10.
You got that 2, right? Got that 2. Domain?
X such that x is the yearly limit equal to 1.
Gosh, I did give her time to write.
And range?
Y such that y is greater than or less than. No,
I don't wanna do that. Negative 10. Okay. Those come from our vertex. Those come from our H and our K, right?
Yes.
Okay, so if x has a leading coefficient or has a coefficient, you've got to set it equal to 0 to find the H, don't we?
Yeah.
So could I write this, honestly, as x minus 1/2?
Yeah.
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 Yeah. Good. My way would have done that. Just reminding you. Okay.
Maybe a little bit salty.
Not at all. Not at all. Okay, square root of 12, square root of x, right?
Yes.
Yes.
Okay, so the square root of 12 side note is what?
2 times square root of 3.
So 2 times the square root of 3. How did you get that, Kale?
Because I just know that.
No, you didn't. I heard you.
Well, because 4 times 3 is 12 and the square root of 4 is 2.
Right. So 4 times 3 is 12, square root of 4 is 2. Perfect squares in there, right?
Yeah.
So
There's a reflection.
this is that. So I have -2 times 2 square root of 3 square root of x plus 4. So this all equals what?
-4
Square root of x plus 4. Now it looks really weird that way, and we probably wouldn't leave it that way, would we? But does it help me graph it easier? Yes. So 4 square root of 3, well, 4 is 4, square root of 3 was like 1.6, so it's obviously bigger, yes? Okay, but it's negative,
Reflection.
so it's reflected over what?
Yeah,
The x-axis. Okay, so it's reflected over the x-axis. 0, 0, is there any h?
No.
No h, so it's 0. And the k is 4. Now, we're not going to do range and domain, we're going to graph it first. Okay, so 0, 4. So here, and here's my new x-axis, yes? Is everything going up 4?
Yeah, and it's gonna be wider.
It's going to be,
Right?
oh, we didn't write wider. Yes, it is going to be wider. Thank you. I was worried about the reflection. Okay, so it is going to be wider, but it's going to be reflected, so it's not going to go up, it's going to go down. Okay, it's going to go down here. So my domain is going to be the same, yes?
Yes.
We don't need to write it because it's the same. But our range isn't going to be greater, it's going to be what? Less than, because there was a reflection. And I do have one more example. And if you want to watch and then go back and watch to write it down, that's fine, or whatever. One more is all we've got. Okay, this one says write an equation from that graph. So our equation is y equals a the square root of x minus h plus k, correct? So from this graph, do you see the h and the k?
You can do an H and a K.
Here's an h and a k. Can I figure out the a from the graph? No. But I have an x and a y, yes? Now these are nicely marked for you. If they were not marked, you would not use this one, would you?
No.
Because it's in the middle. Would you use this one? Yeah, it's a good point. Which one do you want to use?
4 minus 1.
This one? So this is x, y. So if I have an h and a k and an x and y, can I find the a? Yes, we've done this with parabolas before, haven't we?
Yes, I remember that.
So the y is what?
Y is
-1 equals a, the square root, what's x? 4 minus a negative
Yeah.
5 minus 4. So I'd have to add 4, yes? So that's 3.
Yeah.
And this right here is 9. The square root of 9 is 3.
So A equals 1.
So a equals 1. And if a equals 1 and h and k is this, my equation is y equals the square root of x plus 5 minus 4. So remember, don't worry about the negative if it's reflected, because the math will come out negative for that a. That was the last example. We got through that.